For this lesson, we're going to be reviewing once again some of the skills and concepts from the grade 10 course. And in particular, we're going to be focusing on very algebraic concepts. We're going to be looking at the idea of solving systems of equations. So that's manipulating the equations of different straight lines to try to find their points of intersection. And then we're also going to be looking at the expanding and simplifying of quadratic relations. And in particular, we're going to be looking at expanding out sets of binomials in brackets. So let's go ahead and get started. First of all, the idea of solving a system of equations. When we solve, we're trying to find a point where the lines intersect each other. I'm not going to be looking at graphical solutions. Graphical solutions go all the way back to grade 9, and they're the most intuitive. If you've got a nice graph, you see where the two lines cross. But we are going to be looking at solving by substitution, solving by elimination. And the way I'm going to do that is by working through these two examples. So if you're working along with me here, you might want to actually pause now and try to solve one or both of these yourself. And then I'm going to go on and actually go ahead and solve it for you, so you could check your answer that way. So let's go ahead and get started with this first one. We're going to solve this one by substitution. And you can see I've provided a hint here which says sub the x value from the second equation. So here's the second equation. So there's equation number 1, and there's equation number 2. So it says substitute the x value from the second equation into the first equation. So what does that mean? Let me just rewrite this. So here's equation number 1. 3x minus y is equal to 2. And then here's equation number 2. X is equal to y minus 2. Now I've set this up very deliberately to make this a fairly simple situation. And what I'm going to do is I've already isolated this for x. X is equal to y minus 2. So what I'm actually going to do is I'm going to take this x is the same as this x. And so what that means is that instead of 3x minus y, I'm going to rewrite this as 3, but instead of x, I'm actually going to substitute this value, which is y minus 2. And then I go ahead and finish the equation as it's written. So instead of saying 3x minus y, I say 3 times this thing, which is the same as x, because that's what this equation tells us. It tells us that x is the same as y minus 2. So I have now substituted for x the value y minus 2. And the nice thing about this equation is that I only have one unknown. And now that I only have one unknown, I can solve for that unknown. So that's the reason why we substituted. By substituting for x, we got rid of x completely, and now we only have y. And now we go ahead and we expand this out. 3 times y is 3y. 3 times negative 2 is negative 6 minus y equals 2. We're going to gather together our like terms. So on the left side, I'm going to have my 3y minus y. That gives me 2y. And I'm going to take this negative 6 over to the right side, which turns it into a positive 6. 2 plus 6 is equal to 8. Then I divide both sides by 2. And so 8 divided by 2 works out to be a whole number. That's y is equal to 4. Now that I've solved for this, I can substitute that back. X is equal to, but instead of y, I'm actually going to put in the value 4, which we just solved for, minus 2, and we end up with x equals 2. And so when we're solving, our solution is actually a point. So our solution is the point. It's going to have an x coordinate of 2, and it's going to have a y coordinate of 4. So this, another way of expressing this, the reason why I used p here to represent this as a point is because this is the point of intersection. So that's how we solve by substitution. Now if you have a slightly more complicated situation, you might have to rearrange this and isolate. That's what we're doing here. This is called isolate one variable. Now in this case, I gave you equations where the second equation was already isolated for x, but that's something you might have to do on your own. Okay, let's go ahead and move on to our next example, which was solving by elimination. So I've given you two equations. You can see neither of these equations has an isolated variable. Let's call this equation 1, call this equation 2. Neither of these has an isolated variable. And if you do this in your head, if you think, well, could I rewrite equation number 1 so it says x equals or y equals? If I do that, I'm going to end up with fractions no matter what. If I do that with equation 2, I'm going to end up with fractions no matter what. Now, sometimes we can't avoid fractions and we just go ahead and we deal with it. But if we can find a situation that makes it easier, then I would suggest we actually do that. So what we're going to try to do, let's take a look at this hint. We're going to try to match coefficients of the x term or the y term and then add or subtract equations. And when I say we're going to match, what we're really going to do is we're going to manipulate one or both of these equations in order to get them looking so that one of the terms have the same coefficient, or at least the same size coefficient. So let's take a look at 5x plus 2y equals 5. That's equation number 1. 3x minus 4y equals negative 23. That's equation number 2. Now, let's start off by looking at the x terms. So I've got 5x and 3x. So how can I manipulate these so that these are the same value? This is 5 and this is 3. So what number would be our target to turn those into the same thing? And if you need to, you can actually just count upwards. So for example, I could go 3. If I multiplied by 2, that would be 6. If I multiplied by 3, that would be 9. By 4 is 12. By 5 is 15. Whereas if I did 5, if I multiplied by 2, I'd get 10. If I multiplied by 3, I'd get 15. So the smallest number that they have in common, this is the least common multiple that they have of each other, is going to be equal to 15. So how do I turn this into 15x and turn this into 15x? Well, what did I have to do? To this equation, to turn 5 into 15, I had to multiply everything by 3. And to turn 3 into 15, I had to multiply everything by 5. So what that's going to do is if I multiply by 3, I have to multiply everything by 3. 3 times positive 2y becomes positive 6y equals 3 times 5 is 15. Similarly, over here, I multiply by 5, and that's going to be 5 times negative 4y is minus 20y. And 5 times negative 23, that's not necessarily trivial, that's equal to negative 115. So now that I've done this, I could solve these by what's known as elimination. So I can take this equation and rewrite it over here. 15x minus 20y equals negative 115. And then what do I have to do to these two equations to make the 15s go away? Well, what I actually have to do is I have to take this equation, the first equation, and I have to subtract the entire second equation. So what does that give us? 15x minus 15x is equal to 0x. Well, that's good. That gets rid of that. 6y minus negative 20y. It's super important that you're careful about this. We are subtracting this whole equation. So this is 6 minus negative 20, which of course is equal to positive 26y. And similarly, we have 15 minus negative 115, which is the same as 15 plus 115, and that's equal to 130. So y is equal to 130 divided by 26. And if you think that through, you might recognize that, well, at the very least, we can see that 13 goes into each of these. 13 goes into this 10 times, and 13 goes into this 2 times. But 10 over 2, well, 2 goes into itself once, and it goes into 10 5 times. So we actually end up with our final answer here of y is equal to 5. Now normally at this point we would take this answer, we would sub into either equation, and then we would solve for x. Okay, so that's what we would normally do here. But what I want to do is I also want to show you that in this case we actually could have worked with the y values as well. So let's just rewrite those equations. 5x plus 2y equals 5. 3x minus 4y equals negative 23. And so now let's consider, well, what would I do to get these y's to match up? So what can I do to turn 2 and 4 into the same number? Now this one's actually quite a bit easier. I was kind of doing this, I just wanted to start with the x's and now I'm going on to the y's. But if I was doing this as a test question, I would strongly recommend you actually look for the simplest way to do this. So the easiest way to do this is to turn 2y into 4y, because this one is already 4. We don't care about the plus or the minus. I'll show you how we're going to deal with that in just a moment. Now remember, this is review, so hopefully you remember how to deal with that. So what did I do to change 2y into 4y? I didn't do anything over here, so this is just 3x minus 4y equals negative 23. That stays the same. So what did I do to change 2y into 4y? I multiplied by 2. And so 5x becomes 10x plus 4y is equal to 10. And now and again, you can choose to arrange these however you like. I see that I've got 4y and negative 4y, so I realize I'm going to add these together. So the order that I write these doesn't actually matter. Negative 23. And I'm going to add the first equation plus the second equation. 10x plus 3x becomes 13x. 4y plus negative 4y is the same as 4y minus 4y is equal to 0. And then 10 plus negative 23 is negative 13. So when I divide both sides by 13, I end up with x equals negative 1. So you can see I've got my answers here for y and for x. So that means my solution in this case, so therefore my solution is the point negative 1, 5. But I do want to point out that normally we would only solve for one of these, either the x or the y, using elimination. And then we would just sub that answer back into one of the two equations, and that would get us the other result more easily than doing this elimination twice. So only do this elimination one time. You could do it twice, but I would feel like you're wasting your time if you do that. Okay, so let's move on to some skills that we're going to make use of, or some algebraic skills that you should have learned about with regards to quadratics. So we've got two binomials. Binomials are just two terms that are connected through addition or subtraction. So here A is either added or subtracted with B. I've got them as addition. So the first way I'm going to review this is using the distributive property. And what that means is A plus B times C plus D is the same thing as A times this entire bracket plus B times this entire bracket. So what I've done is I've multiplied A into the bracket and B into the bracket. So I've separated these out. And now that I'm at this point, I can expand this, because now I take A multiplied by C and A multiplied by D. So that's A times C plus A times D. And then I take B multiplied by C and B multiplied by D. So that's going to be B times C plus B times D. And this is known as the distributive property. Now we have a shortcut for doing this, which is called FOIL, but that comes from this. FOIL is just a shortcut. And so that's what I'm going to look at next. FOIL stands for first outer inner and last. So what that means is we start by multiplying the first terms together. So here's the first term and here's the first term. So A times C is simply AC. Then we multiply the outer terms together. Those are the terms that are furthest away from the center. So once again, that's going to be A, but now it's going to be D. So A and D are the farthest from the center, so that's going to be plus AD. And now the inner terms, so we've done first, we've done outer. Now we do the inner terms. Those are the two terms that are closest to the center. That's going to be B and C. So that's done. And the last terms are the two terms that are to the right. So that's going to be B and D. And as you can see, just as we had in the previous one, we have four total terms here in our answer, or our expansion, and here we have 4 total terms as well. Another way to do multiplying or expanding binomials is known as the area model. And so what we do is we represent each of the binomials along the edge of a rectangle. And so I've got A plus B, and I've got C plus D. Now I'm only putting those pluses in there because it becomes important if you have subtraction here. For this, I could have just written this as A and B, but putting in the plus sign is actually recommended. And then what we do is we imagine this as this is a rectangle with one side length A and one side length C. So the area of this rectangle would be this side times this side, and that's going to be AC. Similarly, this side A times this side positive D, that's going to be AD. BC and BD. And the overall area is going to be the sum of all of these individual areas. And so from that, we end up with, and the order you write this doesn't actually matter. So I'm just going to mix up the order here. AC plus BC plus AD plus BD. So this ordering doesn't match exactly the ordering I did here, because here you can see my A's always came first. But that ordering is just a matter of style and choice. And sometimes it just depends on how you wrote this. Did you write this A plus B across the top, or did you do A plus B along the side? And so now you might want to practice these on your own. So here's a chance for you to pause the video and jot these down, or if you've got a copy of the notes, you can go ahead and try these using whichever method you like, just to verify that you're doing things correctly and that you're comfortable with them. So if you're going to pause the video, do it now. Otherwise, I'm just going to go ahead and get started. I'm going to use a few methods for doing this. This first one, I'm just going to go ahead and use FOIL. I think that's what most of us will be using most of the time. So I'm going to start with first. So this one I'm going to use FOIL. So my first is going to be x times 2x, which is 2x squared. My outer is going to be x times negative 3, so that's minus 3x. My inner is going to be 4 times 2x, which is plus 8x. And my last is going to be 4 times negative 3, and that's going to be minus 12. And the last step I need to take here is I need to gather like terms. The only place where I have like terms are these middle terms. So that stays 2x squared. Negative 3x plus 8x is equal to plus 5x minus 12. Now this is one, part B is one where actually I find students continue to go wrong even after the grade 10 course and into the grade 11 course, and I wish I didn't have to admit this, but I see this mistake being made in the grade 12 course as well. So first of all, if you don't remember the pattern that goes along with this, I really recommend the first thing you do is you actually write this out as two binomials multiplied by each other. 2x minus 3 times 2x minus 3. Because that's what it means. We're squaring, that means we're taking a copy of it and multiplying it by itself. If you write this, it'll remind you that you really do need to use FOIL. The biggest mistake that students make when they're doing this is they square the first one, they get 4x squared. They square the second one, they get positive 9. and they just leave that as their answer, and that is incorrect. Squaring it means you have to go through this whole process. Now, just to show you something different, I think I will go ahead and I'll do this one as the area model, because it actually is going to illustrate that missing piece as well. Why are we missing something there? And so the area model for this, again, I just start with that rectangle or that square that I break into 4 pieces. 2x minus 3, 2x minus 3. 2x times 2x is 4x squared. Negative 3 times negative 3 is positive 9. But as you can see, and it makes it so clear here, we've missed entirely these 2 parts of the area model. Negative 3 times 2x is negative 6x. 2x times negative 3 is negative 6x. And then when we write out our final answer to this, we end up with 4x squared, which we had before. But negative 6x and negative 6x makes for a negative 12x plus 9. And then this last one, you could do it either way. Oh, it's not the last one. So there's another opportunity for you to jump ahead there. I'll work on C. So for this one, again, I'm just going to go ahead and use FOIL. 3x times x is 3x squared. The fact that we've got y's here, don't let that intimidate you. Just follow the algebra. So the outer is going to be 3x times 5y. That's going to be 15xy. The inner is going to be negative 2y times x. Now we could write this as negative 2yx. But because multiplication is what's known as commutative, which means we can order it in any way that we want to. 2 times y times x is the same as 2 times x times y. So it's actually preferable to write this as minus 2xy. And then we've got the last terms, negative 2y times positive 5y. That's going to be minus 10y squared. And then I rewrite combining these middle 2 terms, which is easier if I write them in the same form, where I write xy instead of yx. 15xy minus 2xy is plus 13xy minus 10y squared. And then this final answer, I've got this leading coefficient 3. I really recommend you leave that until the end. So don't multiply that in until you've done all of this other multiplication. And then I've got 2x minus 5y, 2x plus 5y. Now we can go through the actual process of either using FOIL or the area model here. But something else that I want you to think about if you haven't noticed it already is there is a pattern here. We've got the first term minus the second term, and then the first term plus the second term, and otherwise the terms are identical. And so that pattern is known as a difference of squares. And if you need to, you could go back and review those patterns. The 2D notes are available to you on the web page. So if you recognize that, that's terrific. And I'll come back and talk about that briefly at the end. But if I do this honestly, meaning I just go ahead and use the brute force algebra, the pattern, we don't need to recognize the pattern, even though it can make our lives a lot easier. So 2x times 2x is 4x squared. Outer, 2x times 5y is plus 10xy. Inner is going to be minus 10xy. And then last is going to be minus 25y squared. And we get an interesting result here, which is we have a positive 10xy and a minus 10xy. Those middle terms are going to cancel and result in 0. So we actually end up with, if I simplify inside the brackets, I end up with that. And that's our pattern. That's our difference of squares. I just squared the first term and I squared the second term. This actually goes back to that mistake I said that some students continue to make up here, because they treat this using the same pattern as difference of squares, and that is incorrect. So there's only one binomial expansion that has this, and one of them is adding and one subtracting. The order that they're written doesn't matter. And the last thing we need to do, because this question did say expand and simplify, is multiply this 3 into the bracket. 3 times 4 gives me 12, and that's on an x squared. And 3 times 25 gives me 75. That's a negative though, and that's on a y squared. Another mistake that I see, and it's not as common as the first one that I pointed out to you, is sometimes students will use this 3 and they'll multiply before they expand the binomial, and they'll multiply the 3 into this bracket and they'll multiply the 3 into this bracket. And that's a mistake. That is wrong to do. And the reason is because when you multiply the 3 in, it's been used up. There's no more for it to give. So you can multiply into the bracket if you want to, but you can only multiply this 3 by one of these brackets. You can't multiply it by both of them. All right, I believe, yeah, that is it. So that's it for this lesson. We're getting into some actual homework out of the textbook now. There are also those quizzes from the grade 10 course, those mastery quizzes that you might want to take a look at. And just to make sure that this stuff is kind of flowing quickly and easily through your mind as we're reviewing this.